My presentation is on onboarding data to Filecoin. The first thing I'll do is actually cancel my video because I'm in a low bandwidth situation, so apologies for that. But hopefully we also have some questions later on if we have time. So without further ado, let's get started. Can everybody see my screen? I'm assuming yes. Okay, great. Okay, well, sounds good. Well, the learning goals for this short presentation are fourfold. Number one, I want to identify some examples of large clients and why they choose Filecoin. Secondly, I want you to understand involved client data and what tools may be useful to you, overall giving you a better understanding of the end-to-end process and how to get started. And I also want to give you a sneak peek in terms of what we're building internally and how we're working with the ecosystem to build better tools, better processes in terms of what next. All right, so starting with the basics, I'm sure you all understand this. You're all already here in terms of seeing the value of the network, but I think it's worth double clicking into why people are actually onboarding data to Filecoin. So there's a bunch of reasons, really, right? It's open, it's robust with over 4,000 storage providers around the world. It's pretty much free if you're actually leaning into verified data and the Filecoin Plus program that Beep is going to talk a little bit about. And of course, it's auditable, right? There's this unique technology that allows us to verify that the data has not been tampered with. So all these things, the four things, are big drivers in helping us help see the value of our network and onboard their data. But I think what I also want to leave you with is that there are opportunities here where the way the data is constructed and onboarded to the network allows us to uniquely suit certain workflows. And what I mean by that is that we can have some interesting stories that I can share with you later or probably afterwards, given the amount of time we have, of folks in research, for example, really leaning into these DAGs as a unique data structure and allowing them to do sort of storage and retrieval operations that you simply can't do in a sort of Web 2 world with AWS or GCP. So I think it's really important to note that there are some really unique things that we offer that are helping us really craft a narrative that helps Web 2 clients understand why to upload data. And of course, more crypto native clients understand that this is something that they should lean into in terms of large data sets. So a couple of examples, right? Internet Archive is a really good example of a client that has very large data sets for archival purposes. Berkeley is another example. Seal Storage just did the announcement a couple of months ago with a specific research group within Berkeley, storing vast quantities of scientific data on the network. OpenSea is a really good example of a Web3 native client storing all NFTs on through NFT.storage via IPFS. And Absentia is also a really good example that I like to point to as a native, it's a sort of a decentralized science DAO that is wanting to upload very large data sets involving neuroscience to enable really decentralized science. And so you can start to unpack a couple of these big important use cases, right? First of all, we see clients with very large data sets. Second of all, because of the functionality of the network currently, we're also seeing that most of the use cases involve archival. Number one, because it's so cheap. Number two, because it is just the capacity that we are currently offering is very large, and the incentives are aligned such that we have this ability to replicate very large data sets into very large periods of time where we can renew these deals continually. And sort of the goal is to have perpetual data storage. So I wanted to, first of all, highlight a couple of really great examples of some of the clients that we are working with, both on the Web 2 world and on the Web 3 world. Couple of figures. We have 127 gigabytes of data in active storage deals today. And on a daily basis, as of yesterday, for example, we have 727 terabytes of data, of verified data being onboarded. As Stefan mentioned, we have very lofty goals in terms of not just targets for total cumulative data, but also the amount of daily data onboarded. And we're counting on all of you to help us not just have new clients, but also work together to create new tools that enable us to more seamlessly onboard data, because that is one of the big things that is currently quite difficult and one of the current areas of focus for Protocol Labs. There are lots of moving pieces, as I'll point out, and we need to make these processes work more smoothly together to really hit those targets. Another thing I wanted to point out is cumulatively, in terms of verified clients, we have 907 unique clients. So we're getting to very large numbers here. And the other thing I want to highlight is we've hit the mark where 10% of these, so about 90 of these unique clients, have uploaded a total of 100 terabytes or more. So we're really seeing a quick progression across these buckets from 0 to 1, 1 to 10, 10 to 100. And the other thing I'll leave you with is all the data that I'm presenting. We have a dashboard that is available to you all. And please, I'll make sure that you get access to this as you progress through ESPA and start working with clients. So we're talking about really big numbers and very fast growth. We're targeting between almost 1% of growth daily. So to get to these 5 petabytes a day of data onboarded per day and 500 petabytes total of verified data. All right, so the main thing that I want to discuss today is the main stages involved in onboarding data. Like I said, there's currently a lot of moving pieces. We're doing a lot of work to try to connect all of these in a way that enables you to be more efficient in onboarding data, whether that's you, meaning a storage provider on behalf of a client, or a client who wants to go through the process themselves. In either way, depending on how you slice and dice things, there are several stages to go through, and I'm going to go through a couple of the most important aspects. So the first step, which is almost optional, but I think it is worth highlighting, and Deep is going to go into much more detail later, is getting data cap. Data cap is this resource that you can use to store verified deals on the network. And it is something that is quite essential today for uploading data, because a lot of storage providers, the vast majority, are uploading verified data. And so data cap is something that a client needs in order to onboard data. The main thing that I want to highlight is actually the 4 steps below: deal preparation, data transformation, deal making and transfer, and finally deal management. So there's a whole bunch of different steps involved in actually getting the data from a place, whether it's the cloud, whether it's on-prem, transforming it so that it is compatible with our network for the proofs, for data transfer, and finally for managing everything in the process. So starting with data cap, real quick. Data cap, when allocated to a client, can be spent by the client in these storage deals with storage providers. So data cap is allocated to the client, not the storage provider. And there is a very robust system whereby notaries allocate this data cap to clients to subsidize reliable and valuable storage on the network. The process involves going through submitting an application called an LDN application for larger data sets. And that'll kick off a whole process whereby notaries verify the intent of the data owner with regard to what data is being stored, for how long, and whether it's stored in a sufficiently distributed manner with regard to the different storage providers and geographies. So there's definitely a lot more to learn here, but I'm not going to spend too much time, but that is a really important step. Now, with regard to deal preparation, the main question here is, where's the data owner's data currently stored? There are instances where it's stored in AWS and you have to extract it. There are other instances where it's on-prem. We have to figure out where it is and how to get our hands on it. Then there's typically a process of aggregation or splitting, right? When you're dealing with very large data sets, you'll have to chunk up the data into these 32 gigabyte large deals. And so we need to prepare the data so that it fits into this chunk. And that will either involve splitting very large files or aggregating smaller ones. So there's a process by which we need to do that. And as I'll mention later, there's some indexing that you may want to do in terms of actually keeping track of what is where. And finally, encryption. This is a sort of special edge case because well, obviously clients may want to encrypt their data, but currently we're still working through the place that encrypted data actually has in the Filecoin Plus world. In other words, that process was built for large public data sets. And obviously, as we move into the enterprise world, and they say 80% of all data is stored in a sort of enterprise context, we will obviously have to approach encryption as a use case that is, well, important to discuss and handle. And so that's something that our team is specifically exploring as a mechanism that may take place in the Filecoin Plus ecosystem. All right, data transformation is also a process that can be a little bit confusing. I mean, once you understand what's actually going on under the hood, I think you will understand why that's important. But the problem is there's a lot of different utilities and libraries out there that enable you to do this data transformation. But broadly speaking, it involves two big steps. Firstly, the preparation of a CAR file, which involves taking a file, producing a DAG, right, a IPLD, direct data cyclic graph, and then serializing it into a CAR file. And then secondly, taking that CAR file and putting it into what's called a piece, and then computing its root hash. So these things are not necessarily super complicated. They will involve some compute. And there are utilities out there that enable you to do this. Typically, we're looking at this not being super expensive in terms of time, but it will take some amount of effort to understand how this can be parallelized, for example, and overall how long this will take. But the data transformation piece is essential, and we are working on consolidating a couple of different libraries into these different tools that can help this be a more seamless part of the onboarding journey. This is an example of what actually a COMP refers to. Well, you can see, for example, the COMP is really just a root hash of this very large DAG. And I thought this diagram was actually really useful in helping me understand what's actually happening when you're going through these data transformation stages. So once you have the data in its target format, you actually have to propose a deal, right? So you need to propose a deal with a storage provider for a specified number of days. One thing I want to call out is a tool suite called Boost, which shipped with a lightweight client for making deals that can be pointed at for on-chain operations. And the client that ships with Boost currently supports proposing a deal for HTTP retrieval. So currently, or actually until now, the majority of the data transfer involved libp2p and using GraphSync to basically propose a deal and then transfer the files to a storage provider. We have just launched Boost last month, and we're seeing a much better utility for storage providers and data owners alike to actually manage these sort of very large amounts of deals and kind of keep track of things, but also crucially transfer them efficiently over HTTP. So basically, you can just build all your CAR files, host them on a server, and then have a storage provider pull these car files one by one or in parallel to then basically establish a deal on their end. The other big thing that's important to note, as Stefan alluded to, is that we're working on systems or processes that enable data owners to ship data to storage providers offline. So this is an example of Seagate's Live Mobile Array. We're also working with other vendors, but the goal here is to make it as easy as possible for a client to receive one of these at their doorstep, to plug this into their system, to upload the data to the device, and then to ship it out to a storage provider. Most of the times, the storage providers themselves are the ones that are managing this process. We're also seeing examples of storage providers replicating data amongst themselves using this. So not just the first mile, but the replication stages as well. So this is an area that we're exploring quite deeply to make sure that there is the infrastructure necessary for there to be something reliable and something fast and cost-effective for transferring very large amounts of data offline. Doing so domestically is much easier. Doing this internationally, for example, from the EU to the US, is something we're still navigating, considering GDPR requirements, for instance, but it is something that we're working on. And if folks want to get involved in this at all, please let me know. This is an example of Filecoin Plus registry. So as a client wants to find a provider, they'll go through these storage providers that are signed up. So as Deep will allude to as well, it's important to make sure that you are findable and make sure that as a client seeks storage providers in a particular location or the particular reputation, that they can find you as a provider. And speaking of reputation, there is this Filerep, which is a platform that actually keeps track of these miner IDs, the amount of essentially the committed capacity, average deal price, things like that. This is an area that is actively being worked on. But again, it's important to keep in mind that as any two-sided marketplace, it's important to keep track of reputation and ensure that you are putting your best foot forward when data owners want to find you. All right. Now, lastly, deal management is also something that's important to highlight, because when you're talking about, let's say, 1 petabyte, as you divide that into these 32 gigabyte chunks, you run into, you're really handling tens of thousands of deals. And so keeping track of everything can be quite hard. What people do is they construct an index of what original file is in which piece, at least, and ideally wanting to keep track of the actual name of the file, some metadata, et cetera, whatever makes it as easy as possible for the retrieval use case. The second piece is also managing deals, right? As a storage provider, you will want to have some control over when you retrieve the data from the data owner and when you start sealing. And so I want to highlight again, which we shipped last month, as a tool with a really elegant web UI that actually gives storage providers the access to manage deals, to view the progress view progress in data transfers, monitor disk utilization, sealing pipelines, and more. So I really encourage you all to take a look at the Boost documentation to understand, to help you understand how to be more effective in onboarding data. Okay, a couple of things I want to leave you with. I mentioned that we are trying to consolidate all these steps into more frictionless tools. And I want to highlight a couple of tools that we are working on. Singularity is a tool that's been being built by a couple of folks in our ecosystem with the goal to provide an end-to-end tool for petabyte scale data preparation, transfer, and management. It is currently in use for Slingshot v3, which is a program to onboard public data at scale. And we are also leveraging this tool for a couple of large clients in Asia, Korea, and Australia specifically. And with good success. So I encourage you to take a look at Singularity on GitHub. I'll provide the link in a moment as a potential tool that will help you, maybe not in the beginning to just sort of actually start onboarding data, but at least you can actually dig into its architecture and start understanding how things connect. Estuary is another excellent tool that's being built by the ecosystem, a couple of folks internally as well, where the goal here is to also abstract a lot of the storage activities within Filecoin and provide a simple, easy to use UI that essentially, collects all the data that might be needed into these 32 gigabyte deals, and then ships them to a certain number of reputable providers. And it's trying to have everything sort of as easy as possible to use. There are certain things that you will need to explore if you're using Estuary for very, very large data sets above, for example, 100 terabytes. But there are certain use cases already emerging of people successfully using this tool for things, for data sets that are sort of that size. So as I mentioned, Singularity, I encourage you to take a look at the URL below on GitHub, go and read it, go and star it, go and contribute to it. It's a tool that is probably the closest thing we have to an end-to-end CLI that actually does everything from deal preparation, from the car files. It also stores an index on IPFS and really makes things as easy as possible for data owners and storage providers alike. This is a quick example of Estuary. This is a dashboard that is provided for its users with all the deals that have been made and their status. So it's a great way to monitor how things are going, also to retrieve things via IPFS. You can go to estuary.tech and get started there. All right, so we only have a couple of minutes left. I'm sorry that I've been rushing things so much. I'm a little tongue-tied, but I want to also highlight a couple of things that we're working on. Priority number one for me and my team is to build better tools to make things more usable, more robust, and also complement these with better documentation. This is an area that's been moving super, super quickly, and we want to make sure that we consolidate things and have things be easier to digest, process, and repeat, especially for folks like yourselves who are just getting started on this journey. But I also want to make sure that as a growth team, we are working together to share leads. We currently have lots of people who are exhibiting interest in Filecoin coming through surfaces like largedata.filecoin.io, and we need to have a better system for qualifying these leads and sharing them with storage providers like yourselves. Another thing to discuss is better infrastructure. I mentioned Project Cybertruck, which is this sneakernet infrastructure that we're trying to establish. There are other efforts to build BGP, for example, that will help to enable more robust replica building across different storage providers in different regions. But along those lines, another thing that I also want to share that I didn't actually highlight here is I want to make sure that Protocol Labs and all the SPs, including all the SPs coming from ESPA, work together. Because until now, what I've observed is a lot of these tools are sometimes being built by storage providers where we don't have much visibility. Sometimes we're building things where storage providers don't have much visibility. So it's important for us to establish a really solid relationship amongst ourselves. I really encourage you to participate in Slack, to attend our events, and I promise to do the same. My team will do the same. We'll make sure that we're there to build better relationships, to help each other build better tools and infrastructure for everybody. And the last thing is, we also, you can't manage what you can't measure. And so a big part of what my team is doing is building better analytics to understand where clients might be getting stuck in their onboarding journey. Any contributions from the ecosystem that, in this area are also very, very welcome. Okay, and with that, we're exactly on the mark. Unfortunately, I don't think I have any time for questions. But my handle is JFIADEIRO. Ask Stefan or anyone there for my contact on Slack, and I'll happily provide more details, more documentation. I hope this was a useful beginning for your data onboarding journeys. Thank you so much.